Swayam Prabha. Digital India. Educated India.
Hello. Today we will be discussing a very interesting pump called claw pump. As the name suggests, it looks like a claw of a tiger. Okay. So, basically the pumps that I am going to discuss in claw pump and screw pumps, there and also the scroll pumps, etc. I will be using the words called rotors, and synchronously they are rotating opposite direction. These words will come again and again, like the one we have used in roots blower. Okay. So, there are two claws and two rotors. They will rotate in opposite direction and they will not touch the housing, and they will start getting volumes decreasing and increasing at various locations, and those decreasing volumes create compression, and that will be exposed to an exhaust valve, and increasing volumes create suction, that will be connected to the suction port. So, if somebody says in 1 minute you tell the claw pump, you will have to say two claws protruding out of two rotors, not touching to a housing, they rotate in opposite directions, and there will be walls which are exposed to the cavities behind these claws in such a way at various times the various compressions and expansions going on, and they will try to create suction and compression, and synchronously they are connected to the inlet and exhaust valves. Thereby you will get evacuation at the inlet, and outlet will be either exhaust to atmosphere if it is a single stage, or you can couple it, or you can boost it with a roots blower. Okay. So, in the concepts covered in this lecture will be claw pump introduction, construction of a claw pump, working principles of a claw pump, little bit about its characteristics like pumping speed and compression ratio, which are very important, and finally, we will touch upon applications of claw pump. But anyway, claw pump applications, selectivity of this pump compared to other pump and all, we will be covering them in the other side of the course, the second half of it, where applications will be covered in detail. At that time, we will come back to these applications more in detail, but here I will only give you a list of applications. Okay. As I told you, claw pump is also a dry pump. Because all the four pumps are now I am discussing, diaphragm pump, claw pump, scroll pump and screw pump. They are medium vacuum dry pumps. They can be boosted with another dry booster pump called roots blower, and they can be backing an ultra high vacuum dry pumps like turbo pumps or cryo pumps or ion pumps. They can also do themselves a process vacuum in certain medium vacuum applications where oil traces are not allowed. They are also extremely useful in pre-evacuating analytical instruments where the hydrocarbon signals are not allowed, and they are used in semiconducting industry where the contamination coming from the hydrocarbons are not allowed. So, out of these things different constraints are met with different dry pumps, and claw pump is a very good pump. It is catching market nowadays, and it is replacing some of this old oily type of pumps, but they have their own market. When it does not matter whether there is a lubricating oil or not, we want only quantity of vacuum, then even now rotary pump is the best. The moment you require dry, you have to go for this type of pumps. The figure here shows a typical cross section of a 4-stage claw pump. 1, 2, 3, 4 type thing, and inlet, exhaust, etc. And this is connected to a shaft and then motor, etc. Common shaft. So, the two class here, this is in a protruded portion of a rotor extended in a housing. Two such class are there, and they are exposed to openings called inlet opening in the front face and outlet opening here in the back face. As a whole, they will try to produce vacuum here and exhaust this side, and such stages are connected 4 here with inlet, exhaust. You can also air blast and other applications like an accessories, that is a different thing. But basically it contains 2 counter rotating synchronous rotors. Synchronization is very important. So, you cannot couple 2 shafts, one shaft, okay, and that should be synchronous with a gear to the other rotor. That is very important. Otherwise, they will hit each other and whole pump will be cracked, whether it is a roots blower or this or screw pump or anything. They are highly synchronized rotors, pair of rotors. And gas is transferred axially here and it goes out again, and on top of the front face or back of the back face, bottom of the back face, etc. We will see these things more in detail in the construction. In general, these pumps are more efficient, 30% more efficient than comparable rotary vane pumps, because they are not touching, these class are not touching the housing. In rotary pump, they are touching. So, rotational speed can be very high. You get one advantage, that is driveness. Second advantage is rotational speed can be high, lifetime will be high. They can handle little bit of particulate. They are quite strong class like a Tiger class, and they are quite strong and rugged also, and they can be staged up with 4 stages. Exhaust of one can be connected to the inlet internally. Finally, it is exhausted to atmosphere. So, they can be a good competitor to the rotary pump wherever you not only want good vacuum, you also want a dry vacuum. But then they may have also limitations. They may not be able to produce better than a vacuum or like 0.1 tar or 1 tar, because sealing is not there, oil seals are not there. Okay. The driving pump, driving motor is connected to a shaft seal, and other side there may be grease, etc., but not to the actual process chamber. So, this is a dry pump, they are not touching each other. There can be heating effects, but heating effects may be good also, because compression is going on at relatively higher pressures, there will be heat of compression, and there can be back leakage across these clearances. In spite of that, if you want to have good pumping capacity, that rotational speed should be high. So, all these things in design of these pumps, people have taken care of it. They are also keeping in mind the high temperatures that may get generated inside while designing the bearings and various other seals, etc., at the end of it when it is coupled to the shaft motor. All these precautions they have taken care, and if necessary some purging can be done to cool those portions where excess heat is not allowed, etc. But this heat is also an advantage to us. Even if vapors like water vapor or something is coming from the process into this chamber, because of heat they will never get condensed. So, they can be nicely compressed and going out of that to the next stage or whatever you feel like. And they can also handle hot gases coming in, because body is also hot. So, you will not get any problem, heat related problems to some extent. Excessive heats are not allowed, of course. To some extent this heating is also helpful. But again we have to keep in mind the most important point is it does not have any oil in the working chamber. It is a dry pump, ideal for chemical process applications. where oil is not allowed, and good quality of pumping speed is required, not at a very high vacuum level, maybe 10 millibar, 20 millibar, because most of these pharmaceutical industries, they do not require high vacuum unless you go for molecular distillation, where mean free path is of the order of distance between the source and the substrate. In such applications, very slow distillation molecular level, that may require 10 power minus 3 torr, so that the distance is much less compared to mean free path. But otherwise, most of the process applications, they are in the transition region, having some viscous drag concepts, having some molecular concepts, etc. So, heating effects, heat transfer, some sort of fluid mechanics calculations can be done in the other side, 100 millibar, 200 millibar, you can use CFD. But there are various programs available nowadays, process related softwares are also available even in console package. You can do this even in molecular flow dynamics. So, it is a big field for research, these dry pumps. On one side, it is a challenge to mechanical engineer. Without any seal or lubrication, you are trying to get compression. And the materials, when you get hot, nothing should happen to that. The seals must withstand such temperatures. Okay. And chemically also it is challenging, because some gases may chemically react with these materials. So, you should be careful that there will not be corrosion, etc. All these things are now well taken care, because metallurgy is also getting developed continuously. So, a good combination of metallurgy, chemical engineering and mechanical engineering and controls and good quality designs, softwares have resulted in discovering these dry pumps. These concepts are known, but people did not go, because such materials, such high quality clearances, that machining is not possible. But today very high quality machining is possible. In turbomolecular pumps, for example, a typical mechanical turbine rotates at 1 lakh revolution per minute. Can we ever think? Of course, it is an offshoot of turbo machinery in aeronautical industry. So, technologies are improving. That is why the wet vacuums are getting replaced by dry vacuums. There are many good companies in India who are trying to produce dry vacuum pumps, like dry screw pumps, claw pumps or other pumps, who are saying continuously, all the chemical or pharmaceutical industries or any other high tech industries, you can replace your existing watering or steam jet or rotary pump, etc. With these pumps, you will get these advantages without spending much on that, because the consumption, electricity consumption is more or less same. In fact, it may be less here, because friction is less, there is no touch point. So, that way cost effective analysis has to be done, taking various parameters, and nowadays you have to take care of various other parameters, like what is the longevity, etc. So, this is an advantage. Already I have explained you the construction wise, it is a small two claws are rotating in opposite directions. These two small openings are inlet opening and exhaust opening. So, the cavities, this is called cavity and this is called claw and this is a rotor. These two are rotating in opposite directions. So, these cavities are exposed to inlet wall, this is dotted portion is called inlet wall, this dotted portion is exhaust port, inlet port and exhaust port. There is no valve or anything, it is a port. It is a self-valving arrangement. The rotors themselves close the inlet port, the rotors themselves open when they want. When the compression is going on, automatically rotors also expose that compressed gases to the outlet thing, and they also suck the gases at the suction port. Okay. So, that way you can see a small slow animation here, thereby you can understand the synchronous action of inlet outlet ports and 2 rotors having claws protruding, leaving some cavities behind it, and that regions of those cavities are exposed to inlet port and exhaust port alternatively. They are covering, uncovering depending on the positions of the rotor cavities. Since they are not touching, they can run at 2000 rpm. They are counter rotating, then only it will create compression and expansion. This is the construction aspect. Okay. So, as usual, working principle by now you must have already understood, but I have from a book I have taken, these are 11 stages representing various instants of time, the positions of these rotors, and you can easily imagine the first stage is called, first step is induction. It runs for 5 such stages, that means 5 instants of time you can map, image those things. Then during that time, if you carefully observe the inlet portions, because this is rotating in opposite rotation, the inlet ports are slowly getting exposed to the left side rotor called R1 and right side rotor is R2. One rotor is exposed, one rotor is controlling the inlet port, other rotor is controlling the exhaust port. So, induction is going on through the inlet port and exhaust is going on in the outlet port, which is being controlled by the R2. So, you can read out the 1 to 5 stage here, induction is going on, that means exhaust port is still covered by the R2, but inlet port is slowly getting opened because claw comes to the other side and the cavity behind it is getting exposed. If you go concentrate on the left side now, now you will see, now inlet valve is opened, this cavity is exposed, but outlet valve is still closed. So, same thing I am showing here, 5 positions. Okay. At some time inlet valve is totally closed, inlet note it is not a valve, inlet port is closed because it is self valving, but outlet port starts getting exposed in the R2. That way compressed gases from 7 to 10 we will see, initially suction is going on, that is called induction 1 to 5, then there is a compression going on because isolated volume here, do not look at the back side of it, that will be another cycle coming for the next cycle, but the whatever has been isolated up to 5, after 5 that gas starts getting compressed up to 8 and 9, and after that slowly that isolated volume gets compressed and exhaust valve starts opening, but its opening means the claws which are compressing, they themselves are opening the outlet port. So, inlet port or outlet port, what is to be opened, they decide. Okay. So, that is how exhaust port is opened. What is covered, what is uncovered, that depending on that whether you are sucking, inducting or whether you are exhausting. But during this time there will be a stage called 11 stage, where some bit of locked up between 2 claws, that much is neither getting exposed to outlet nor inlet, it is collected in a way, but it was trapped between 2 claws sometime in between, a small volume. Now you see that volume. That volume will be again added to this, because that was a volume of gas which could not be going into this, but suddenly they are getting trapped and it is getting attached. So, these trapped volumes try to reduce the displacement capacity. That of course is, we cannot do anything on that. There are different designs approaches are there. These mathematically you can design the class surface. It is nothing but an outer circle and this is an inner circle. There is a connection between inner to outer circle across a particular path. Mathematically you can give an equation to that, and then this is another surface. So, all these things, hypocoidal curves, these in mathematics there are several equations involved in this, and there is a lot of research in that. Those who are interested, you can contact me. You can generate your own format of this background, this cavity volume as well as the claw, what is the ID, OD and volumes of compression and speed, depending on that throughput and pumping speeds, etc., and the timings of the duty cycles where inlet and outlet are exposed by the compressing pistons, which are rotary pistons here. It is self-valving arrangement. It is a beautiful pump, and it requires a lot of designing, otherwise they will hit each other, and this requires a lot of synchronization. The gear should not have any delay. There is small slip is good enough. It will become a grinder in no minute instead of pump. So, you have to be careful, but the understanding of induction, compression and exhaust there in other pumps also. Here there is one carryover is there, because in the entire process of 2 rotations, when it comes back to the same position here, because one rotation is complete here, our second rotation comes to that for each rotor. By that time some amount of gas which was there in the earlier cycle gets added to the present cycle. This is called carryover. Okay. So, these are various terms. If you read the book, because of lack of time, it will not be possible to talk again and again same terms. And you can see how they are, see one red color thing and green color things are alternative. One is a compressed portion, inlet and exhaust valves, how they are opening. There are beautiful animations, so you can slow it down and slowly see. A typical single stages can give only the compression ratio is very small. Okay. So, it is only 10 maybe. Then if you have multiple stages, you can have very high compression ratio, not very high, because leak is there at every stage. These cloths are not touching with things, and higher the pressure, the leak is real leak, because mean free path is small, gap is 0.1 millimeter, mean free path is 0.001. So, gas will leak all the more, whereas at 10 power minus 1 or 1 torr, this is also 0.1 millimeter, that is also 0.1 millimeter, leak probability is less. So, all these things go hand in hand in designing clearances and how much is the power requirement, etc. Even then the pumping speed falls heavily by 1 torr with 50 hertz and 60 hertz curves are given here, and multi-stage curves are there, varieties of combinations are there. So, in all these things, what you are trying to understand is how these cloths are made, how to take care of accidents, and how the inlet and outlet ports are exactly synchronously being controlled by the rotating cloths who are actually compressing the gas. All this is a beautiful thing for designers. Okay, there are quite a good number of programs. You can use COMSOL or MATLAB, or you can do lots of, you can put it into mesh and finite elements and what happens at various instant of time, and depending on that what will be the pumping speed calculations, etc. It is a beautiful field for mechanical design people. You can certainly do lot of work in these things, and if you are able to do it, and if you can make your own claw pumps, you can have a startup, and you can say that we manufacture dry medium pumps ideal for modern pharmaceutical applications. Okay. That way, because these pumps, unlike diaphragm pumps, they can handle quite a good amount of gases. Okay. That way it is good. The applications are quite large, like in food processing, food packaging, because drying will be going on, or sometimes foods are very peculiar, food items. For storage, water is enemy. For actual consumption, water is a friend. Unless you have watery things, you cannot eat. This is a rehydration, dehydration is always there, removing, that is called drying. Okay. So, these processes, food processing, food packaging, very important. Similarly, in clinical laboratories also, when huge amounts of the water vapor has to be removed, you can use it. So, that dryness is very important. You can create dryness one by air conditioning, you can also create dryness by evacuation, but you should not, because pressure should not go down heavily, then you do not have oxygen. So, these are all things are there. Central medical vacuum systems are also being developed for scavenging the gases, particularly in corona atmospheres, etc., where continuous fresh air can be there, but this should not be exhausted to the next room, you have to take care. When you design a system based on these pumps, you have to not only understand the pump restrictions, interconnecting things, lot of design issues are there. We will see when we cover the applications. Similarly, there is one good thing going on in wood processing, wood working on it, lifting precisely, even big glass panes, very lifting nicely, even in TV or even our display applications, very large scale things have to be lifted precisely. Such things, these claw pumps can provide a uniform lifting force. And similarly, you can have material transporting, holding in the chemical industry, light things can be flowing very fast by sucking from one side. This is a typically used in most of the pharmaceutical sector, where very light quality, light things can be nicely carried over from one step to the other step in a chemical, in pharmaceutical industries. Similarly, degassing, recently there was a very good application, this is in energy sector, lithium batteries, they are slurries, you have to degas them because these are little bit of electrical things, moisture is not allowed. So, you have to degas them. Similarly, ceramics and bricks, if you try to remove moisture contents or little bit degassing certain things, their properties will be better. Okay. Thermoforming, for example, apply a vacuum the other side and create a pressure difference and use it to form in composite materials or plastics, etc. So, plastic industry, composite industry, they use it in extruders and granule conveying and also composites manufacturing, forming various types of sheets in various industrial applications, etc. And finally, in environmental engineering, sewage degassing, biogas production and soil remediation. So, all these things require a high speed, dry and mechanically simple, energetically favorable, that means it consumes less energy. All these things are now to be answered by the designers who manufacture dry vacuum pumps. That way, the claw pump has come to quite a good amount of maturity level. Today, lots of companies are manufacturing claw pumps. Okay. With these claw pumps, you can design your systems, but pumping speeds are high, but vacuum levels may not be high. If you want to have better vacuum level, you have to have some booster. That way, depending on the quality of the vacuum or quantity of the vacuum, you have to decide the combinations. And sometimes huge amount of suction is there, you should be careful that heating effects will be there. You should have pre-condensers, you should have process condensers like that. And vapors, gases all right, because vapors are different from gases, under compression they get liquefied. So, these while they are handling, you should see to that two-phase flow is not developed, cavitation should not take place within these pump chambers, and lot of jolting will be there and a lot of sound will come. So, silencer designs, etc. All these things go hand in hand along with these technologies, but I can tell you these dry vacuum pumps are having good market in future pharmaceutical, chemical, metallurgical and semiconducting industries, even in space and nuclear and various other applications which are coming up in medical and other things. So, with this we have understood the second dry pump called claw pump with two claws, and you can see that if you want once again, because okay. And right side I have given the source from where I have taken this material, and pumping speeds are quite high, but vacuum levels are not that high. So, with this idea, let us close this section on claw pump, and next class we will discuss screw pump and scroll pumps, that will complete medium vacuum dry pumps, and later we will switch over to ultra high vacuum. That is another concept by itself, and you will find not gas flow or anything, I will start talking molecular flows. That way vacuum technology is a beautiful field. All these classes we are only discussing production, measurement will be there, troubleshooting will be there, system design will be there, applications will be there, lots of other things are there in the way. So, I hope you have understood this mechanism of dry vacuum pump. Thank you very much.